Hello everybody, welcome to day, I don't even know, 7? 7. Let's go 7. Pretend it's 7. Okay? Today we're actually switching gears a little bit. Oh, I didn't change your notes? Okay, so this should say Unit 2, Day 7. Ignore that. Because, it used to be part of Unit 6, but now we're moving it forward. I'm rambling a lot, sorry. Multi-step inequalities is what we're doing today. It's very, very similar to multi-step equations. So you're solving it the same way. It's got like an extra rule you have to be aware of, but you're still solving it the same way. So let's go ahead and get started. It's already almost a minute in and we haven't done anything. So, vocabulary. Inequalities is a comparison of two expressions. So we use less than, greater than, or equal to. We've only dealt with equal to, so now we're going to deal with less than or equal to, less than, greater than, or greater than and equal to. Okay? Solution is a value that makes the statement true. So in this case, we're talking about the inequality. So a value we can plug in for the variable. That would make it true. So if you said x is less than 4, 3 is a solution because 3 is in fact less than 4. Inverse operations are operations that undo each other. We've been practicing this so much. And then step builder notation, just to remind you, is where you use the braces, you put your variable, the line, and then the rule that you have. So before we were doing like x equals 3, our rule for inequalities would be like x is less than 3, or whatever, okay? This is when step builder notation comes into play, because for inequalities, we have so many solutions that can work. So we can't just write every possible number x can equal. So instead we just write it's everything bigger than 4 or something. Alright? Now solving inequalities, we solve just like we solve equations using inverse operations. Sad Meg, who's still sad because they don't know where their x is. But in addition to using sad Meg, we have this special rule for inequalities. And it says if you divide or multiply both sides by a negative number, where's my negative? There it is. You must flip the inequality sign. So if it was less than, it's now going to be greater than. Okay? So let's do an example. We're going to solve it, check our answer, graph it, and write it in step builder notation. Oh, look, I already put it there. Oh, well. Oh, well. So, all right. So to solve this, I'm still trying to isolate the x. So the first thing I'm going to do is add 12 to both sides. That way it gets rid of the 12. I now have 3x is greater than or equal to 21. Divide both sides by 3. I get x is greater than or equal to 7. Okay? So to check it, I'm going to pick a number that is supposedly greater than or equal to 7. So, what did I pick? I can't even remember. Oh, I picked 10. So I picked a number bigger than 7 and then plugged it back into the original inequality. And I'm just going to simplify this and make sure it works out. So 3 times 10 gives me 30. 30 minus 12 is 18. 18 is in fact greater than or equal to 9, so I know it works. Okay, so my solution is x is greater than or equal to 7. To graph it, I'm going to put a closed circle on 7 because of the equal to part. Equal to means we're going to have a closed circle. Open circles if it was just greater than, okay? But I'm going to put a closed circle on 7 because it says we're talking about 7. And then I'm going to have an arrow coming out of that circle pointing to everything that's greater than 7. So off to the right. Alright, step builder notation, I'm just going to put a line, an X, and some braces in front. And that's my answer. Okay? Alright, next page. Now, some are going to be more than just sad Meg. So again, just like with equations, you'll have to distribute, combine, and then solve it, which means moving your terms around using inverse properties. Okay? So example 2, solve the inequality and write your answer in step builder notation. So I'm going to go ahead and distribute this 5 to the negative 3x and the negative 5 here. I get negative 15x minus 25 is greater than or equal to negative 28. There are no like terms on this side. And there are no like terms on this side, so I leave it as is. Now I can go ahead and use sad Meg and the inverse properties. So I'm going to get rid of this minus 25 first by adding 25 to both sides it becomes negative 15x is greater than or equal to negative 3. Now I got to get rid of this negative 15. Divide both sides by negative 15, which should be a warning for you because you're dividing both sides by a negative number, so you have to flip your sign. So it comes out to be x is now less than or equal to negative 3 over negative 15, which simplifies to be positive 1/5. Okay? Or 0.2 if you really want to use decimal. But you guys need to get over this decimal type. Okay? Step builder notation just means to put the line and the x in front. So my answer is that you could have done a check to make sure, but didn't require it, so I'm good. Okay? You guys are going to try that one on your own. Did I not give you a try on your own for the 2-step one? I guess I didn't. Alright? You're going to try this one on your own. Remember, that's an invisible 1 right there. Okay? And then example 3. Same deal. It's just now with variables on both sides. We still follow the same steps. So I'm going to distribute this negative 2 first to the x instead of 3. So it becomes 4x minus 2x minus 6 is now less than 5x plus 6. Now I can look to see if I can combine like terms, which there are like terms on this side. So I combine them to be 2x. Over here there's no like terms, so just that one. So it becomes 2x minus 6 is less than 5x plus 6. Now I can start moving variables. So I'm actually going to move this 2x because I want to get rid of the smaller one. So I subtract 2x from both sides. It cancels out here. Gotta sneeze. Excuse me. So I'm just left with the negative 6 here, and then the 5x minus 2x gives me 3x. Where'd it go? There it is. Okay. Now I'm going to subtract 6 from both sides. Cancels out on this side, so I get negative 12 is less than 3x. Now notice how, even though I've dealt with negative numbers, I have not multiplied or divided anything, so that sign should not be flipped at all. Okay, now is where I gotta go into multiplying and dividing, because I have to get rid of this 3, so I must divide both sides by 3 as well. I'm dividing by a positive 3 on both sides, so I don't need to flip my sign. So I get negative 4 is less than x. Now if you like your x to be on the left side, you can reverse it, but you need to reverse everything. So the x needs to be over here, the negative 4 needs to be over here, and the little alligator still needs to go towards the x. Okay, so you flip the whole thing. So it says x is greater than negative 4. Okay, you can give me either of those. It means same thing. It's totally fine. Step builder notation usually prefers the x to be in the front. Okay, and then you guys will try this one on your own. So give it all a try. You only had 2 try on your own. It's less than a 10-minute video again. But yeah, give some inequalities a go. And if you have any questions, write them down and we'll talk about them next class. Okay? Bye, guys.